As I said earlier in the last talk, I think Lambda is really the first step in a much longer journey. I happen to think that a Lambda-like model is going to become the dominant model in the cloud in a few years. I don't think VMs will go away completely because it's lift and shift, low risk, low latency. But I think for new development, in some number of years now, we're going to see, the majority of it is going to be Lambda-like. But I think the Lambda of today has a lot of headroom to evolve. So, oops, wrong one. So I talked about this in the last talk about spot lambdas. Take a look, think about this from the perspective of the cloud vendor, like I said earlier. So this graph is from a blog post I have. The x-axis is time, y-axis is physical or virtual servers, right? So the very top line there is the current number of physical servers that the cloud vendor has in a data center, right? They've written the money for this. The checks are gone, and it's a sunk cost. And their job is to monetize those things as much as possible. So now, Amazon, by the way, I think cloud is really as much of an economic revolution as it is a technological revolution. And Amazon has really innovated economically as much as technologically. And this graph shows it, right? So the yellow is the on-demand instances. We're all familiar with that, right? There's some time varying amount, and they want to always stay ahead of it. Because if they ever get to the point where, kind of right there in the middle, where the yellow hits the top, that means they have lost revenue. They could have sold more, but they didn't. And so they always want to have a few more physical servers ahead of what they're actually selling. And that's where Spot comes in. Spot is the orange. So previously, before Spot, all that orange was making them no money. They had the servers, they were ready to go, they needed to stay ahead of demand. They can't predict demand, right? They have to stay ahead. And some genius said, hey, and by the way, Spot is an old concept. It exists in all the other markets. There's spot markets in oil, there's spot markets in whatever, pork bellies. So they have spot markets in servers. And what that does is it monetizes the things that were previously unused. Reserve instances are very interesting. Reserve instances are actually futures. They have futures in wheat, they have futures in steel. This is actually a server future. You prepay or contractually agree to prepay for a server in the future. And so that right there is low risk because for the vendor it's low risk. I know if I buy that many servers, I'll be able to sell them because I've already sold them. So I think one interesting thing to do is apply that same model to lambdas. And right now, when an event occurs, the paradigm is, as soon as the event occurs, I launch the Lambda immediately. Well, if there were a way for the customer to say, hey, you know what? I'm not in a hurry. When this event happens, launch the Lambda, but get it done by, there's some flexibility. Get it done by, say, Friday by 5. Or, get it done within an hour. You don't have to do it right now. Just do it within an hour. And if you're doing some dynamic pricing, get it done if it falls below X. So if there's some mechanism for the user to convey some scheduling, Lambda scheduling flexibility to the vendor can do spot Lambdas and do the same thing that they do with spot instances, which is sell it to you cheaper, right? And the benefit to the vendor is exactly the same thing as for instances. They can use it to fill their gaps in their unsold server time. So I think that is going to happen in the future. So this is actually from another talk, but this is how it looks inside Amazon. You have a bunch of Lambdas. They're running on a Linux. You don't get to pick it. It is a Linux. They run multiple Lambdas on the same VM. They never mix Lambdas from different customers on the same VM. They always run separate. And so these Lambdas are not actually just dissociated Lambdas. They're actually a graph. Your Lambdas are calling other Lambdas. They may be calling other services. And so if you can convey knowledge of that graph into the underlying infrastructure, certainly the OS first, perhaps deeper, you can get some interesting things that can come out of it. So today, OSs are thread-centric, right? They schedule threads. They don't have any direct knowledge of what thread depends on what thread. They find out sometimes dynamically with lock contention, but they don't know in advance. Well, if I can convey the graph to the OS or to the thing below the OS, you can use that to predict what Lambda to execute next. You can then use that to hide any cold start latencies, to reduce cold starts. And for the vendor's perspective, their advantage is they can schedule these things on the same physical server, same rack, same subnet, and reduce their internal network traffic. Are perhaps near, these lambdas are all using S3, that particular bucket of S3. I'm going to schedule them right next to that. So I think being able to convey and capture the graph concept and convey that into the vendor's infrastructure becomes really interesting. So you can augment this graph by by keeping history and trace data. The vendor can do this. Of course, they can share it with the user. I'm sure you'd find that interesting. The graph can be inferred, just from my experience using Erlang, most of the graph can be inferred from static code inspection, because a lot of times it's just lambdas are calling other lambdas, or it's all a configuration, right? They clearly see when this API is hit, call that lambda. So a lot of it is there for inspection. And any things that are missing, they can capture the rest of the graph by dynamic monitoring. You don't need to know the entire graph to get some advantage. So I think the interesting thing about Lambda is that today your AMIs are a black box to the vendor. You drop this whole thing on there, they don't really know what's in it, they just do what the hell they're told. Lambdas actually decompose that black box and expose more of the constituents to the vendor's underlying infrastructure, allowing them to do things that'll be beneficial to them and to you. Oh, the other point is that, of course, the graph will extend across machines. It's not going to be only on one machine. It'll also include, really, to think about other cloud services as just giant nodes in the graph, right? And factor that into the scheduling of your workload, which means, of course, that the graph scheduling is distributed, right? From the vendor's perspective. Everything in the Lambda OS and lower is in the vendor's world, not your world. So transparent persistence. So one of the common patterns for a Lambda is you get lit. First thing you do is you read a bunch of data from a persistent store. You do some math and you write it, right? Because lambdas are stateless. Well, if we could have a mechanism for the user, the developer, to say, you know what, whenever I light that lambda, I'm always going to use these objects. And you can specify that in configuration and or in code, then the cloud vendor's infrastructure can auto-restore them, have them already there waiting for you when your lambda lights up, and can save them automatically for you when your lambda dies without the developers having to worry about writing any of that code. And you can use knowledge of the lambda graph to prefetch some of these objects. And this can be specified either in a static configuration kind of thing like they do now and or in your code. And this basically takes some of the load off of the developer. You don't have to worry about all these, F reads and F writes. You just light up and do your thing. And of course, you'll need access control. The other thing here, as I said earlier, cloud is as much an economic revolution as a technological revolution. What's really happening here is that customers are spending their limited IT budget on cloud resources to get some output, some business process, whatever it is. If we have our Lambda graph, and if we have a mechanism for customers to be able to say, this path through the graph, or perhaps these starting or ending points in the graph, represent some business process or something interesting that we're doing at the business level, then you can actually allow customers to quantify what they're getting for their money, where their money is going in business context, and what they're getting for it, right? You effectively make business processes a first-class citizen. So I didn't say this earlier, but I think when I was talking about the Lambda graph, really the Lambda graph is hierarchical. Nodes themselves can be graphs, right? So if you can encapsulate a bunch of lambdas and say, that is a reusable unit, and maybe it's also some boundary of a business process. So as I said in the last talk, Amazon has this thing called X-ray. I think it's a really good step down this path of being able to capture on a per lambda basis where your time and your money is going, and even better, capture on a path basis. So if I have some business process, the purple one or the blue one, the purple one is I'm selling books, and the blue one is I'm selling DVDs, and this is my entry points and exit points for each, then they can actually, whatever the path is through your Lambda graph, from entry to exit, they can quantify time and money and how that's spent. I think I have one more here. So you have your Lambda graphs, and obviously Lambdas are always hitting storage because they're stateless, and there's some storage service. And simplistically, there's a storage engine, and there's the actual bits sitting somewhere in flash or disk. And there's objects that these Lambdas are contending for. So the database actually sees this. It can go, oh, I see Lambda number 1 and Lambda number 49 are going for the same object. He's locking objects or records as is executing. So he has information about contention. And so if you can integrate that data contention knowledge, which is seen by the storage engine, with the Lambda graph, you get then the whole picture, right? You get the data flow and the control flow dependencies, allowing scheduling on a more efficient basis.
Unique. All right. Excellent. All right. Do we have any final questions, or dare anyone actually prognosticate yourself on what the future of lambdas might be? Anybody want to do that? Some sort of, I don't know, let's see, blockchain lambda. No, that sounds too obvious. Let's see. Lambda I. Lambda I? Lambda intelligence. Lambda intelligence, there you go. Sounds good. Perhaps, oh gosh, what's the new kind of computing that has 3? Quantum lambdas. Ooh, that seems like that should have for sure been on your slide.
Oh, man. Well, it was a lightning talk. I only had so many minutes.
Oh, right. Quantum lambdas, yes.
That was my next slide.
Something that I've been puzzled about for a while with lambdas. I think it could be kind of cool to show how you can get like an existing Rails app, for example, running on that, where instead of running some kind of Rails service, you just spin up new lambdas.
Yeah, I mean, it could be interesting to look at auto lambdification tools, right? Here's my thing. I have a framework. I can easily see how microservices, web service could just map one-to-one to lambdas, right? Every route is a lambda. It's kind of
quick. Somebody go get the domain name Lambda on Rails.
Ooh.
That's going to be huge.
I'm sure this is like my last thing.
Wait, hold on.
This is a vaguely recall. I have a friend at this company, they're on Lambdas basically. And I think he told me about some tool that basically did that Lambdified a Flask app.
Oh, cool.
And so that's why their app, I'm like, I was asking, you? And that's what they did.
Gosh, that reminds me, isn't somebody somewhere supposed to be analyzing code, like in GitHub or something, and then automatically relating those to like reusable components? Somebody somewhere was supposed to be doing something like that. Now I'm thinking they'll just go through all the GitHub code and try to take all those and turn them into reusable lambdas, right? There you go. You have something else?
Yeah, I just recalled the Flask project. That's called Zappa, like Frank Zappa. Yeah, you take a Flask app and you add Zappa library to it, and it just makes it into Lambda.
If you're called like that, then there are some people who are going to love it and other people who absolutely hate it.
Oh,
right. Okay, you had a question?
I was just going to add that from the perspective of the graph being first class things, step functions are an easy, obvious precursor.
Yeah, yes. I mean, Lambda and step functions, and isn't there like a workflow thing? There is a lot of overlap there, which can be subsumed under really one service.
Good. This is starting to feel kind of unconferencing right here. So I think it might be a good segue into the next session. But let's go ahead and wrap it up for Jack. Thank you very much, Jack.
Thanks, guys.